Hello everyone, welcome to Reactify Labs. Today we will talk about time series databases. Time series databases. Okay, so uh, where is time series database used and why do we need time series database? So if we need a graph or a data which has like time stamped data points. For example, let's say financial analysis that okay, right now the price of something is this, now this. So for storing this kind of information, we need time series databases. Now let me, if I need to query that what was the price of a particular stock on this day at particular time. So we cannot store this for every second. We cannot store the price for every second in a SQL database, right? Or a NoSQL database, right? Actually, time series is also a NoSQL database, but yeah, you got my point. So no other database can handle this kind of information. Similarly, for let's say monitoring system, let's say you have to monitor something, um, or let's say you have an IoT device at home which monitors like your daily temperature or daily room temperature. So that does these kinds of things. So this continuous kind of data, this cannot be stored anywhere else. So that's why we need time series databases for this. Now that we know where and why time series databases are used, let's talk about it. So let's start with discussing the structure that we are going to follow today. So we will start with the introduction of time series databases. Okay. So first we will talk about the introduction. Next, we will see the characteristics of time series databases. We will see the architecture after that. Architecture. Next, we will see querying. How do we do querying in time series databases? After that, we will move to challenges and considerations for time series databases. Then we will see the real world applications, and in the end we will talk about the advantages and limitations of time series databases. And from now onwards, instead of writing time series databases, I'll write TSDB. Okay. So let's start with the introduction. A time series database is a specialized database optimized for storing and querying time-stamped data points, making it ideal for applications dealing with temporal data. Okay, so it's a specialized database. It's a specialized database optimized for storing and querying time-stamped data points. Means the data points will have a timestamp attached with it. Querying time-stamped data points. Making it ideal for applications making it ideal for applications dealing with temporal data. Dealing with temporal data. So TSDBs efficiently handle large volumes of time ordered data, enabling fast and scalable storage and retrieval of information. It is vital for applications such as IoT, financial analysis, monitoring systems, and any domain where understanding data trends over time is crucial. So, what's the important factor? If we have to understand the trend of the data over time, So for that, we use time series databases. Okay. And why TSDBs? Because they efficiently handle large volumes of time ordered data. Large volumes of time ordered data, enabling fast and and scalable storage. Scalable storage and retrieval of information. Right? Great. Now let's talk about the characteristics of the TSDBs. First one is, obviously, as we talked about it, the data must be time stamped. TSDBs focus on managing data points associated with specific time instances, facilitating chronological analysis. Sorry. Next is high write throughput. Because the writing happens every second, right? So we need a high write throughput. Designed to handle high volumes of incoming data, providing efficient write operations to accommodate continuous data streams. It's not like SQL where whenever somebody pushes some data, then only it will write to it, right? So continuous writing happens here. Next, compression techniques. It often employs specialized compression methods to optimize storage and handle data efficiently, considering the sequential nature of time series data, right? As I said, the data keeps coming every second, so we need a way, right? We need a way to compress that, because obviously if we just store the raw data, it will consume too much memory. So we need a way to uh, sorry we need a way to compress the data and store it, so that space can be optimized. Okay. And still the data can be handled efficiently, so that there is no data loss. Okay. Now let's talk about the architecture of the time series databases. Architecture. First is data storage. TSDBs utilize optimized storage structures that organize data for efficient timestamp based retrieval. Common approaches include columnar storage or compressed data formats to enhance storage and retrieval efficiency. Next, indexing strategies. Advanced indexing mechanisms are employed to accelerate queries that target specific time ranges. Techniques like B trees, bitmap indexing, or specialized indexing structures are chosen based on the database design, ensuring rapid access to relevant temporal data. Next is scalability. Architectures are designed with scalability in mind, often leveraging distributed systems. This includes sharding data across multiple nodes or employing clustering strategies to handle the increasing volume of time series data. Horizontal scaling enables databases to grow seamlessly with the data load. And retention policies. Time series databases incorporate configurable retention policies to manage the lifespan of the data. These policies define how long data points are retained, helping to optimize storage usage and ensure relevant historical data is preserved. Now let's talk about querying in time series databases. Querying. So there are different types of queries. First one is time-based queries. So time series databases are good at executing queries that involve time intervals. The database's query language allows users to retrieve data points within specific time ranges, facilitating operations like aggregations, filtering based on timestamps, and downsampling for summarization. Next is analytical functions. Time series databases support a range of analytical functions tailored for time-based computations. These functions include statistical analysis, rolling averages, trend analysis, and anomaly detection. These capabilities empower users to gain deeper insights into temporal patterns and trends within the data. Next is complex event processing. Some time series databases integrate complex event processing capabilities. This allows real-time analysis of streaming data, enabling the identification of complex patterns and events as they unfold over time. And temporal joins. So in scenarios where data sets are temporally related, time series databases often support temporal joins. This feature allows users to correlate data points across different time series, facilitating comprehensive analysis and decision making. You might ask, what is temporally related? It means, let's say there is one time series data which goes like this, or there is another data at the same time in another database. Let's say it was getting generated like this. I don't know, maybe one is of A kind, one is of B kind. Temporal means it's near, like if at this point something happened here, and if near that point something happened here, right? So within the same time, okay, or around the same time. So we can like make sense out of these two data points which are almost at the same time, and we can do joins to get some insights from that. So yeah, I'm talking on very high level, I know that, because we don't need to know about it right now, because we are not specifically trying to master the time series database. We are trying to understand the concept of time series database and how it is helpful in certain scenarios for system design interview questions. So that's why I am just talking on high level about it. Okay, now let's talk about the challenges and considerations in time series databases. Challenges. So first one is data volume and retention. Managing large volumes of time series data while determining optimal retention policies poses challenges in storage planning. Balancing decisions about data retention duration and granularity is crucial for efficient storage usage and historical analysis. Next is scalability. Scalability is critical with the growth of time series data, requiring robust horizontal scaling strategies. Implementing distributed architectures across multiple nodes or clusters is essential to handle increasing data loads. And data consistency. Ensuring consistency across distributed nodes, especially in horizontally scaled architectures, presents challenges. Strategies for maintaining synchronization and consistency among replicas must be well defined to prevent discrepancies in timestamp data. Okay, next let's talk about the real world applications of time series databases. Real world applications. First is IoT and sensor data. Time series databases excel in handling data from IoT devices and sensors, crucial for trend analysis, anomaly detection, and monitoring device performance over time. Because these kind of devices emit data continuously, and we can easily use them to detect an anomaly. Like, let's say there is some nuclear power plant and there is a sensor attached to it. If this sensor detects an abnormally high temperature, it might know that okay, there must be something wrong with this, and it can alert it. So for these kinds of things we need this time series data. Okay, next is financial analysis. Time series databases are widely used in the financial sector for tracking market trends, stock prices, and other time dependent financial data. As I talked about in the beginning of this video, facilitates real time analysis and historical trend identification essential for informed decision making. And monitoring systems. So, vital for systems monitoring, time series databases efficiently track performance metrics, errors, and operational parameters over time. It is fundamental for ensuring the health and stability of complex systems. Now, let's talk about the advantages and limitations of time series databases. So, first, we will talk about the advantages. So, the best advantage is fast retrieval of data, because assume that you have to query like let's say last 1 hour data, or like 1 hour data from any day, and you have as many as or as less as 3600 data points. If we talk about like per second generation of data, what if it is per millisecond, right? So if we just query an SQL for that, you know how much memory it will consume and how much time it will take to give us that kind of data. So that challenge is not there with time series databases. So it enables fast, rapid retrieval of timestamp data, supporting analytical operations with minimal latency. Next, specialized operations. Tailored for time-based operations, offering efficient querying capabilities for temporal data analysis. And streamlined storage. Optimized storage mechanisms for chronological data, enhancing overall database performance by prioritizing the temporal aspect of the data. Now, let's talk about the limitations. So, one limitation is complexity, because as you know, the more sophisticated a system is, the easier it is making your job, the more complex that system's implementation is. So implementing and managing a time series database can be complex, requiring specialized knowledge in the domain of time dependent data and database administration. And it's highly use case specific. So highly effective for applications dealing with time dependent datasets, but may not be optimal for scenarios where temporal considerations are not central to the data. Careful consideration of use cases is essential for optimal database selection. Okay, so that's all there was about the time series database. I hope this gives you a good understanding of TSDBs and enough knowledge to talk about it in your interviews. So yeah, if let's say you are asked to design some system like stock market or stock broker kind of system, or some kind of um, monitoring system monitoring system, or like a metrics collection system. So in these kinds of systems, you should talk about databases. Like when you talk about databases, you have to mention that it's a time series database. And if somebody asks a follow-up question about time series databases, this video gives you a good understanding of how to tackle those questions. Okay. So yeah, that's all for this video. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.